Welcome to 15-2, the Law of Cosines. In the boxes you'll notice that I have three different formulas, but really what we want you to see them as is basically one formula for the Law of Cosines, and we'll explain how each one basically works the same. The first thing to note is that the Law of Cosines works with a side angle side case as well as a side case. Later in the chapter we'll be talking about other cases using the Law of Sines. So for the first example, I kept it with ABC so you can kind of see how the formula matches up. But they give you side A is 8, B is 12, and C is 10. Now, geometrically, we know this makes a triangle because the two smaller sides add up to be bigger than the third. When using the law of cosines, it's very important that you solve for the biggest angle in the triangle first. So in that case, this would be angle B. So what we want to do is we want to isolate the side opposite angle B. So that goes on the left-hand side. So whatever angle you're solving for, the side opposite it must be isolated on the left-hand side. Then you just take the other two sides and square them. And you subtract 2 times the product of those two sides. And then you write the cosine of B, because that's what you're solving for. Now when you do the math, it's very important that you understand the algebra. 100 plus 8 squared, which is 64, is 164, minus 160 cosine of B. It's really important that this is where students make a mistake. This cosine of B is a variable. It's attached to 160. So therefore, 164 minus 160 cosine of B cannot be combined because they are unlike terms. So what we must do is we must subtract the 164 to the other side. And we get negative 20 equals negative 160 cosine of B. Then we divide by negative 160. And we get 0.125 is equal to the cosine of B. And we know from last chapter that we can evaluate this by doing the inverse cosine of 0.125. And we'll end up getting 82.8 degrees. Remember, you got to be in degree mode this chapter. And so that's your answer, 82.8. And if you wanted to, you could find the other angles using law of cosines. But in this case, what we would have to do is set up another triangle and solve it. I'm going to leave that for you to do if you'd like. For time's sake on the video, I'm going to move on. Again, solving the triangle just means finding all the sides and all the angles. So basically, you'd have to do the law of cosines one more time, and then you could do the supplement of 3 angles adding up to 180 so that you could basically find the third missing angle. Next example, measuring a pond. How wide is the pond shown in the figure below? Round to the nearest tenth. So really what they want you to do is they want you to find this distance x. So in this case, this is a side angle side case. So what you'll notice is you're trying to find x. X is going to be the isolated side on the left-hand side, so x squared is going to equal the other two sides squared, 152 plus 131 squared, minus 2 times 152 times 131 times the cosine of 48. Now you have the included angle, so that makes it a side angle side case. So this one you can do basically on your calculator if you want. You get 40,265 for the first two squares added together, minus 39,824 times the cosine of 48. When you do the math, you're going to take the square root of this entire thing. There's no need to do the plus or minus case because we're talking about geometrical shapes. We're talking about distances, so the negative is going to be disregarded. So 116.7 feet would be your final answer. Last problem. Softball. Now, don't worry, you're not going to have to know softball or how to play softball or things like that, but I just thought this is an interesting question. The pitcher's mound on a softball field is 46 feet from home plate. The distance between the bases is 60 feet. How much closer is the pitcher's mound to second base? How much closer is it to second base than it is to first base? Now, if you'd like a challenge, go ahead and pause the video and see if you can figure out. I gave you a hint about how much closer the pitcher's mound is to second base. So that should drive your thinking. But go ahead and pause the video if you want a challenge and see if you can figure it out. If not, continue to let it roll. I'm going to show you how to do it. So basically, common sense would tell us that the pitcher's mound bisects home plate. The line from the pitcher's mound. It would make sense to put a pitcher's mound off center. And because this is 60 and 60, we know that basically this is a 45-degree angle over here, a 45-degree angle up here. So we know that second to home, we're talking about that whole distance, is going to be 60 square root of 2. Because remember, x and x rad 2 is the special relationship in a 45-45-90 triangle. And we know that it's 90 degrees because first base is making a right angle. Now, for second to the pitcher, that would leave 60 square root of 2 minus 46, which is approximately 38.9 feet. Now, if we want to solve for y, one thing that we can do is use the law of cosines. Y squared equals 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of 45. And remember, we know what the cosine of 45 is, square root of 2 over 2. However, because we're doing with decimals and we're doing with distances, I'm okay if you use the calculator. So we're going to get y squared equals 5,716 minus 5,520 cosine of 45. Again, take your calculator, take the square root of both sides, and we'll get y equals about 42.6. So therefore, seeing how much closer it is, we're going to take 42.6. We're going to subtract 38.9, and that's going to leave us as 3.7 feet closer. Well, that concludes our quick video notes for today, 15-2. Good luck on your homework, and good luck with your formative assessments. Have a good day.